Let us continue to talk about data preprocessing by focusing on data cleaning, data integration, and data transformation. Starting with data cleaning, there are two major things that you will face when we try to clean the data. One is deal with the missing value, the other one is about the noise data. So let's take a look at this. For data cleaning task, the first one, like I said, is fill in the missing values. Out of all the attributes on the tuples that you have, some block might just missing, no values over there. So how do we deal with that? How can we put some values in that without discarding the items? And we can have some educated guess, or we can throw it away, or we can fill in some global value. That's something that we want to look into. The second problem is about identifying the outliers and smooth out the noise data. This can be addressed by what we have seen previously using the box plot by identifying the majority Q1 through Q3. We can use that as the range and identify the outliers so that we can remove those things or smooth those noise data out. And therefore, in this subsection, we are going to more focus on fill in the missing values instead of working on the outliers. So missing data, it's totally possible to happen all the time in real life, and that can be due to equipment malfunction. So the equipment is not successfully detect anything, and therefore we are not able to put a value into the box. Or it can be inconsistent with other recorded data and thus deleted. So they may find this value is totally weird, so that it remove it while the data is being entered. Or when you try to merge in the informations, one of the information is not there, so that there's no values can be put in. Data not entered due to misunderstanding, so that's human errors, and that happens all the time. Certain data may not be considered important at the time of the entry, and so that the data coming from that, say, data source may totally ignore these values, while other sources of the data do record it. While all the data are merged together, those values are ignored, and therefore we will have missing values in that spot as well. Not registered history or changes of the data, and that's going to be the historical situations, and therefore does not store those values. It is important this. A missing value may not always imply an error. Sometimes it can just be unknown or not applicable. So there's a lot of different situations that can happen on the missing data. And therefore, how do we handle this? The easiest one, of course, is ignore the whole tuple away. So saying that this data set has, say, 20 attributes. As long as there's going to have one attributes that are missing, we are going to throw this tuple away. Of course, if you have a lot of tuples, a lot of information, through 10%, 20% of the data out of it might be okay. However, sometimes to get the information or to get the tuples, such as patients, are very costly. To get some hospital data because of the identity limitations or experimental setup. The data set that you're working on is probably always like about only 100 patients, and that is considered as good data set already. So you don't want to throw those patients away, and therefore you try to fill in some possible values for the missing values, and therefore you can use those information. So another one is going to fill in the missing value manually. So that is going to be something like hiring an expert, sit down in front of a computer, look into each box that are missing values, and then use his experience to manually put in a value that he think this is going to be the best guess. This is like manual operation. Of course, that's one way of handling, but it will cost you a lot, and it has a lot of overhead over here. So how do we fill in the values through the computers? And that's what computer science people or computer scientists try to deal with. And therefore, there are several ways of doing that. First of all, it is totally possible to put it a global constant, so that looking into this value, you think the average height of the American male is this value, so that as long as there is a missing value on the height, they just put in that specific value. So that is one way of dealing it. The other one is finding the average. So instead of using the global value of the overall situation, we can look into this data set, try to find out what is the average height in this set of the data, and we fill in into that value. The attribute mean for all samples belong to the same class. So this is going to be similar to the second choice, but this time saying that for all the patients that have diabetes, maybe there's only half of the patients that you have the diabetes, and you use the patients with diabetes to look into the value and then find the average to fill it up. So that's also another way of guessing a more educated value. The most probable value, so looking into this scenario, interference space as using Bayesian formula or decision tree. So build up some machine learning model to guess the value. So of course, this is going to be something that we will learn a little bit deeper while we go into the Bayesian formula or decision tree, those kind of classification regression models. Finally, there's also a possibility that using clusters, the idea of the cluster, we can group all the things together, and then when we try to guess a missing value, we use the cluster's average value to look into that. So this is going to be using what we call unsupervised learning approach to do the guess values. So there's a lot of different choices, and that's why data cleaning is an active data mining problem. After we look into the data cleaning, let's look into data integration. So when we try to merge data coming from different sources, there's what kind of problems that we will see and how do we handle that? Obviously, one problem is about the redundancy. Since you collect similar data coming from different sources, is there some data that are duplicated, and how do we remove it, or how do we handle that? That lies into the area of what we call the data integration. So for this topic, it combines data from multiple sources into a coherent storage, and so that you can see maybe in the A source using customer ID, the B source using customer number. They may match, they may not match with each other. So you need to find a way of handling that. Just like your UCA ID number, most of your ID numbers started with 000 something, and some of our ID number is starting with B as a boy, B00 something. So how do we make sure that they can understand each other and then well integrate all the information together is going to be an important part in this type of the research. So detecting and resolving data value conflicts for the same real-world entities, attribute value from different sources are different. So that even though you know the two people are the same people, but the value are not matching with each other. Maybe one is taken 1 year before, the other one is after the disease has been in effect. So the values may not matching with each other. How do you handle that? There's also possible reasons, including different representations using the different scale, such as using the metric versus British units. So there's a lot of different things can happen in this type of the data integration problems. Redundant data also need to be removed. So the redundant data occur often when the integration of multiple databases, so that we can use objective identification. The same attributes or object may have different names in different databases, and we need to identify those. We can also remove some derivable data, such as age and the the birthday, you can derive from one to the other. So those kind of things that are also some attributes that we want to remove. And of course, to make sure we do the best operations in this kind of things to remove the redundancy, correlation is actually one important mathematical background can help us to identify. So if one tuple and another tuple has a very strong correlation, that's most likely indicating that the two tuples are coming from the same source. So that's something we would use in terms of the removal of the redundant data. Careful integration of the data from multiple sources may help reduce or avoid redundancies and inconsistencies, and so that we can improve the data mining quality as well as the speed of the operation. So this is going to be also a very important stage in the data preprocessing. Finally, data transformation. So the data that we get can have a lot of different formats. It can come in from different sources. Think about this. When we gather a patient's height as well as the weight, they are totally different things. The metrics are different. The value representations are different. But if we want to find the similarities between the two patients, how can we treat the height as well as the weight into distance? How do we calculate the distance between those two? So this is a very important topic. Before again moving to the data mining process, we need to transform our data so that the programs can do those calculations easily. And therefore, there are several things that can be done in the data transformation step. One is smoothing, remove noise from the data, including the binning, regression, and clustering. We can do aggregation, we can do generalization, normalization, attribute constructions, etc. So let's look into this as an example. This is a real data set that I have been working on in the bioinformatics area. So what it's looking at is that they have different yeast with different numbers. So these you can consider as the different genes operations. And then you apply different experiments on those things so that you can see the values are having big differences. And how do we handle this kind of data set and then try to make it a reasonable operation? It requires our data normalization. So first of all, what I would do, or what I did in this experiment, is that I try to normalize all the data into the value between 0 and 1, so that I can easily understand what kind of the data is over there, and I can calculate their distance without being skewed by some huge numbers. And therefore, that is what we need to deal with the data normalization. There are there's actually many different ways of handling it. Two most popular approaches that I often use, as well as the researchers often use, is using the min-maximum normalization, as well as another famous statistical operation called z-score normalization. So for minimum and maximum normalization, it's actually very easy to understand. While we try to normalize the values, we try to find out, saying that I want the minimum value between is 0 and the maximum value is 1. And I want to transform all the values into 0 to 1. So how can we do that? It's actually very simple. Based on the value that you're looking at, you minus the minimum value divided by the gap, the highest gap in this attribute. So that is maximum minus the minimum. And in this simple case, you can normalize the values into between 0 and 1 already. If other than 0 and 1, say you want 0 to 10, or you want 5 to 10, or 5 to 50, you can have your maximum value, minimum value that you want to generate it, and then you can use the rest part of the formula to help you achieve that. So let's look into an example directly. saying that the income range between 12,000 to 98,000. So you can see that that is the income range, and we want to normalize all the values in between. So because this is the minimum and that's the maximum, you want to normalize everything into 0 to 1. So now for an income that's 73,000, what you would do is using this value minus the minimum value divided by maximum minus minimum. So that is like the whole range in this attribute, and you will get that value divided by that value equals to 0.716, so that you can make the range in between 0 and 1. Like I said, if you don't want the range between 0 and 1, then you will be able to change this part by changing the maximum value over here, minimum value over here, plus the minimum value. So that can give you a very well normalized values in here. The next approach is called the z-score normalization. This one is not going to give you a value between 0 and 1, but it gives you a z-score. And z-score is actually very helpful in understanding how extreme or how unlikely it's going to happen by looking into the value using the map of the z-score. So to do z-score operation is actually another very simple approach. You have your value minus the average of the attribute divided by the standard deviation. As long as you do that, of course, you need to calculate the average of the attribute as well as the standard deviation of the attribute. Once you have those two values, you can convert all the values into a z-score operation. And in that case, it is much easier for you to understand the values compared with several thousands, and some of them are hundreds or even single-digit values. So these are the tools as well as the formulas that I want to introduce to you guys regarding to the data preprocessing. In our next class, we will start talking about once we're done with the data preprocessing, how do we store those values into what we call a data warehouse, and how do we utilize the data warehouse to find the target data for us to do the data mining.